Next, the question becomes, how do we actually find the inverse of a 2 by 2 matrix? So we have to be given a matrix, and then how do you find its inverse? Well, the inverse says, for a 2 by 2 matrix says, first of all, that you want to find its determinant. Well, remember, its determinant is found by doing the A times D minus the B times C. Notice that it goes on the bottom of a fraction with 1 on the top according to the formula. So that's what we're doing right here, which means that you have to be careful that the determinant doesn't equal 0. Why? Because you can't equal 0 on the bottom of a fraction. You cannot divide by 0, so be careful. This means that whatever the determinant is we don't want it equaling 0. We can't divide by 0. Be careful. Notice we multiply the 1 over the determinant by a 2 by 2 matrix. It is not the same as the original matrix. What we've done is we've taken the A and the D, and we've actually, we've swapped them. So you swap the A and the D. Notice with the B and the C, you're actually going to leave them where they are, but you're going to swap their signs. So the A and the D, you would actually swap order. So A and D, you swap order. And on B and C, you actually swap the sign. So on B and C, swap signs. What do I mean by swap signs? If B was positive, it's going to be negative. If B was negative, it's going to be positive. Same thing with C. Now, let's go ahead and try to find the inverse of two 2 by 2s. So let's look at problem A. Well, problem A has us looking at the matrix 1, 2, -1, 0. Well, first of all, let's go ahead and find its determinant. Let's call this matrix A because it's problem A. So we want to find the determinant of A. Well, the determinant of A, remember we do the cross multiplication first, which is 1 times 0, which is 0, minus the other cross product, which is, in this one, 2 times -1, which is -2. Be careful, then that gives us minus a negative, which will turn into a plus or a positive. So that actually gives us a determinant equal to +2. So the question is, what does the formula tell us to do to find the inverse? Well, it tells us that the inverse is going to start out with 1 over your determinant we just came up with, which is 2, times a new matrix. Well, the new matrix has us swap the A and the D's order. So the 1 was in the A slot, the 0 was in the D slot. We're going to switch those around. It'll be 0 first, then 1. Then what the formula also says is for the B and the C, we're going to leave them where they are, but we're going to switch their signs. So B was -1, it's going to become a +1. And C was 2, it's going to become -2. Now be careful, we are almost done. We actually have to just do the math now. We have 1/2 times the matrix. So we actually have to multiply that 1/2 that's out in front to everything inside of the matrix. We have to go ahead and do that multiplication. Size of the matrix won't change. Well, multiplying this out, 1/2 times the 0 will give us 0. 1/2 times the 1 will give us 1/2. 1/2 times the -2 will give us -1. And 1/2 times the 1 will give us 1/2. So our final answer for the inverse of this matrix would be 0, 1/2, -1, 1/2. So that is our final answer there, that matrix. Now let's try another one. Let's look at problem B. Again, we're going to start out, I'm going to call this matrix B, so we need to start out by finding the determinant of B, which means we're going to start by finding its first cross product of A times D. Well, -6 times 2 is -12 minus our other cross product. Well, our other cross product in this one is -3 times 4, which is again -12. Now notice what's going to happen. We have minus and negative here, which will turn into a plus or a positive. So that means we get -12 plus a +12. Well, what is -12 plus a +12? Well, that's 0. Well, there's a problem here. So the formula says that we would do 1 over whatever the determinant was, which is 0. We can't divide by 0. So what does that mean? It means that there is no inverse. We can't find it because we'll end up dividing by 0, and that isn't possible. So there is no inverse.